Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we'll go through everything you need to know for the final exam. So there's a lot on the exam and I've listed all the topics here. So the two topics in red, they're for advanced classes only. I'm going to go through every topic on this list except linear equations because I feel that I'm sort of going to cover that in simultaneous equations and it's going to be a bloody long video anyway. So let's get started with percentages. So you probably already know percentages are just another way to write fractions whose denominator is 100. For example, 30% is 30 over 100. 45% is 45 over 100. So to find 45% of 64, of just means times. So I take this number 45% and I just times by 64. I get 28.8. So we can use this process to increase or decrease numbers by a given percent. If I want to increase a number by 34%, that's just the same as finding 134% of the number. So I can go 1200 times 1 plus 34 over 100. See, 1 is 100%. So I've got 100% plus 34%. 134% of 1200, and I get the number 1608. So in this next one, I'm decreasing by 34%. The only thing that will change is that there will be a minus in the brackets. So you probably know if you want something that normally costs $1,200 and it's discounted by 34%, you're only paying 66% of the price. So what we're doing here is 1200, 100% minus 34%. And for that, we should get $792. And you can use these two formulas if you want to increase or decrease a number by a given percent. So, in these last two, let's look at this one here. 34% of a number is 1200. What is the number? This time, unlike the previous cases, we don't know the number we started with. We want to find the original number. So whenever you want to find the original number, you divide, because this is what we're doing. We're saying 34% of some number gives us 1200. So to find what number goes in that box, instead of timesing by 34 over 100, we're going to do the opposite. We're going to divide by 34 over 100. So we just go 1200 divide 34 over 100. So the answer we get has decimals. I'll just give it to one decimal point. It's about 3,529.4. If I take 34% of this number, I get 1200. So in this one, we're saying price of a TV was discounted by 34%, now costs 1200. What was the original price? So again, we're finding the original amount. This time we're saying what number, when you decrease by 34%, gives you 1200. So normally to decrease by 34%, we times by 1 minus 34 over 100, just as we did here. But because we're finding the original amount, we're going to divide. So this is going to be 1200 divided by 1 minus 34 over 100. Or in other words, 1200 divided by 66%. Because if we've taken 34% off the original price, 1200 represents 66% of the original price. So if we put that on a calculator, we get another decimal, 1818.18. I'll just round it to 2 decimal places this time because it's money. So that's what the TV originally cost. If you decrease this number by 34%, you get 1200. So please remember, whenever you're finding the original amount, as we were in these two examples, you don't times, you divide. All right, let's go on to simple interest. So interest is extra money. It's extra money that you owe when you borrow from a bank, or extra money that you receive if you invest money, put it into an account with a bank. So the formula for simple interest, I equals PRT over 100. I is the interest, P is the principal, which means the initial amount, R is the rate as a percent, and T is the time. So R and T must be in the same units, or else you must change them. So let's look at this example here. Borrow $5,000 at 3.2% per annum, which means per year. Simple interest for 30 months. How much interest will I owe? Well, I want to use this formula here. The problem is R is per years, T is in months. So what I'm going to have to do is change T so it's in years. So 30 divided by 12 is 2.5. 30 months is 2.5 years. I needed to make that change. So now T is in years and the rate is per year. So now I can just use the simple interest formula. So it's going to be I equals P, initial amount, principal, times rate, times time, now in years, all divided by 100. And so putting that on the calculator, the answer is $400. So that means if you were to borrow this $5,000, you'd have to pay back the $5,000 plus an extra $400 in interest. All right, let's look at this example now. So this time I'm investing $8,000, 6% per annum simple interest. After how many years will my investment double? This formula is the same whether you're borrowing or investing. But this question's different because I'm not asked what is the interest. I'm asked after how many years my investment will double. I'm actually being asked to find T. So you can also use this formula to find not just I, but P, R, or T. If you're finding P, R, or T, you take the same formula, substitute in everything you do know, and rearrange for what you don't know. So we've got I equals P. Well, we know P is 8,000 times R times T, which we don't know, over 100. I want to solve for T. Now, if I invest 8,000 and I want my investment to double, I want to have 16,000. So that means I actually want to earn in interest 8,000. If I earn 8,000 in interest, my investment will be worth 16,000. It will have doubled. So I just need to solve this equation for T. So what I'm going to do is I'm just going to put these numbers on my calculator to make things a little easier. So if you put 8,000 times 6 divided by 100 on your calculator, you get 480. So this equation becomes 8,000 equals 480 times T, and the way that we get rid of timesing by 480 is by dividing by 480. So T will just be 8,000 divided by 480. And so the answer we get is 16.6 recurring. So I'm just going to round it to one decimal place. It's going to be 16.7 years, or 16 2/3 of a year. That's 16 years and 8 months. That's how long it will take to double. All right, let's now go into compound interest. Remember, this is only for advanced students. So let's say I wanted to invest $10,000 at 10% per annum. 10% of 10,000 is just 1,000. What was happening in the previous examples with simple interest, this would mean my balance, the amount I have, would go up by 1,000 each year. So I'd have 11,000 after 1 year, 12,000 after 2 years, 13,000 after 3 years, and so on. But with compound interest, it's going to get bigger quicker. At the end of year 1, I'm going to have 11,000. But then at the end of year 2, I don't increase by 10% of 10,000. I increase by 10% of 11,000. So it'll actually go up by 1,100. And then year 3, it's going to go up by 10% of this, which is $1,210. So it'll be worth this. And so on. It's increasing at an increasing rate. But we don't want to do these calculations this way, find out how much after each year, because that will take forever. Instead, I can just use this formula up here. So let's say I invest $10,000 at 10% per annum. I'm going to find out how much money I would have after 30 years. So just so you're aware, compounded annually means I recalculate the interest at the end of each year, like I was doing here. So I just use the formula up above. So the amount I have is P means principal again, what I started with, times 1 plus R. R in this case is 10 over 100. Now, N is the number of compounds. So if I compound it annually for 30 years, I'm going to compound it 30 times. So putting that on calculator, to the nearest dollar, I get 174,494. So just be aware, this is how much I have. This formula for compound interest calculates how much you have rather than calculating the interest. If I wanted to find how much interest I've earned, I just take how much I have and subtract the principal. All right, let's now move on to Pythagoras. So Pythagoras' theorem is used in right-angled triangles. We label the two shorter sides A and B. The longer side, called the hypotenuse, is always facing the right angle. So Pythagoras' theorem says that in any right-angled triangle, this length squared plus this length squared equals that length squared. So we can use Pythagoras' theorem to tell if a triangle like this is right-angled. So here, shorter side squared plus shorter side squared, 5 squared plus 10 squared equals 125. But 15 squared equals 225. In this triangle, a squared plus b squared does not equal c squared. So this is not a right-angled triangle. So we can also use Pythagoras to find unknown sides of right-angled triangles. So let's start here. So here we are finding x. It is the longer side, the hypotenuse, because it's facing the right angle. So what I can do is I can rearrange this formula and just make c the subject. So c is just the square root of a squared plus b squared. C is the longer side. In this case, C is like x. The longer side's x. So x is just going to be the square root of 12 squared plus 5 squared. Put that on your calculator, it will be 13, because 5 squared plus 12 squared equals 13 squared. So in this second one, we're finding one of the shorter sides. So rearranging this and making A the subject, you get A is equal to the square root of C squared minus B squared. So note, adding when we're finding the longer side, subtracting when we're finding the shorter side. And it has to be C first. Otherwise, you'll get an error in your calculator. So this side here, which I've called x, it'll just be the square root of longer side squared minus shorter side squared. So this one doesn't give me a whole number. If I want the exact answer, I write the square root of 78. And if it's rounded, I just put square root of 78 on my calculator. I get 8.25 approximately. So that will be in meters. All right, let's look at this last one. So we can also use Pythagoras to find the two shorter sides of a right-angled isosceles triangle. This triangle is right-angled, but also isosceles because two sides are equal. 6 is a longer side because it's facing the right angle. So this is what we have. We have a squared, shorter side squared, plus shorter side squared equals longer side squared. These two sides are the same. So x squared plus x squared gives 2x squared, 6 squared gives 36. I now just need to solve this equation by undoing everything that's been done to x. So the first thing I'm going to do is divide each side by 2. And then the way I undo squaring is square rooting. So x equals square root of 18 is the exact answer. And if I put it on my calculator, I get about 4.24. That's the rounded answer, 4.24 centimeters. All right, let's now move on to a bit of algebra. So on this slide, we're going to expand brackets. So starting off with the case where we have just one bracket, we use the distributive law. So what we do is we take the thing out of the brackets and distribute it to everything inside the brackets by timesing. So for this one, I go 4 times x and 4 times 3. So that's what expanding means. I start with some brackets and end up with something that has no brackets, 4x plus 12. So I do the same thing here. I go minus 6a times 2b. So a negative times a positive is a negative. So this will be minus 12ab. And then minus 6a times minus 3c. Two negatives multiplied together give a positive. This will be positive 18ac. So sometimes you'll be asked to expand and simplify an expression like this. Don't forget your order of operations. Here we're going to do the brackets first. We're going to do this first. We're not going to go 18 minus 9 first because we do multiplication before addition. So if I leave the 18 alone and expand the brackets, minus 9 times 2, minus 9 times minus x, negative times a negative is a positive, 18 minus 18, they cancel out. That equals 0. I'm just left with 9x as my final answer. So we also need to be able to expand where there are two brackets, and each bracket has two terms in them. So to do this, we use the FOIL method. So to do these first brackets here, we go first, the thing that's first in each bracket, x times x. Outsides, so that's x times minus 5 is minus 5x. Insides, 3 times x. And last, the thing last in each bracket is minus 15. So what we have to do is now collect like terms. This term and this term are like terms. The other two are not. These are like terms because they both have an x. So x squared, no like terms, leave it as it is. Minus 5x plus 3x is minus 2x, and I leave the minus 15 alone. So x squared minus 2x minus 15 cannot be simplified. That's my final answer. So we're going to do something similar here. So we're going to go first is x times x. O for outsides is x times positive 8. I for insides is x times negative 8. And then finally L for lasts, minus 8 times positive 8. Negative times a positive equals a negative. So once again, we collect the like terms. 8x minus 8x is 0. These two middle terms cancel each other out. We're left with x squared minus 64. Okay? Now, there is a quick way to do ones like this, where you have the same two terms in each bracket, but one's a plus and one's the minus. You can just square the first, square the second, and stick a minus between them. If you don't understand that quick way, that's fine. You can still use FOIL as I did here. So this next one's a perfect square. So remember, when you square something, you're timesing it by itself. So this is 2x minus 1 multiplied by itself. Let's use FOIL again. So first is 2x times 2x is 4x squared. So then O for outsides is 2x times minus 1, positive times a negative. I for insides is negative 1 times 2x. And then L for lasts, negative 1 times negative 1, negative times a negative is a positive. Now I have to collect like terms. Minus 2x is minus 4x. So I get minus 4x squared, minus 4x plus 1, and I'm done. So let's now look at factorising. So factorising is actually the opposite of expanding. Here we have expressions that don't have brackets. We're going to write them with brackets. This is how we factorise. We calculate the highest common factor of all the terms. Then we write that out the front of the brackets, and then inside the brackets divide each term by the highest common factor. Let's look at the first one, 4x plus 8. One term, two terms. The highest number that goes into 4 and 8 is 4. So I put that out of the brackets. Then in the brackets, I go 4x divided by 4. Or if you like, what do I times by 4 to get 4x? That's just x. What do I times by 4 to get positive 8? Well, that's just positive 2. And we're done. If I were to expand this using the distributive law, I'd get that. So factorising and expanding undo each other, just like multiplication and division. So let's look at this example here. So the highest number that goes into 25 and 40 is 5. But there's something else that's common. They both have a b. Both terms have a b. It's also common. It goes out the front. So now I say, what do I times by 5b to get 25ab? I times by 5 to get to 25, and I also need to times by a. What do I times by 5b to get to negative 40bc? Well, I need to times by negative 8 to get to negative 40, and I need to have a c. So over here now, I actually have 3 terms, but I'm not going to do it any differently. I'm going to find the highest common factor of all terms and write it out the front. Now, these 3 terms have no letters in common, but they have a factor of 3 that's common. 3 goes into 3, 3, and 6. 3 goes into all of the terms. It goes out the front. So what do I times by 3 to get 3x? What do I times by 3 to get negative 3y? What do I times by 3 to get 2z? And we're done. All right, this last one here is a bit tricky. Firstly, the numbers. The highest common factor of 28 and 63. So just go through factors of 28, see which of them go into 63. 28 doesn't, 14 doesn't, 7 does. 7 is the highest common factor of 28 and 63. But they also have letters in common. They both have an x and a y. So I'm going to write 7xy at the front. So what do I times by 7xy to get this? Well, I need to times by 4 to get to 28 and x, so there's an x squared. What do I times by 7xy to get this? Well, I need to times by negative 9 to get to negative 63, and I need the z. And then I'm done. All right, let's look at a bit of linear relations now. So we're going to quickly go over calculating the distance, midpoint, and gradient of a line segment. So first, we're given the points of this line segment. Let's plot it. So A is the point minus 2, 3. So it's really important I label my axes with numbers, so then I actually know where to plot A. So A is minus 2, 3, which is up here. B is 6 minus 3, so I go across to 6 and down to minus 3. So B is there. So remember, when you're given a point in brackets like that, always x coordinate listed first. So let's join up these 2 points. So here we have what we call a line segment because it has a clear start and an end. If it doesn't start or end, we call it a line. So this is the line segment we're talking about. Now let's calculate its gradients, distance, and midpoint. So first with the gradient. So the gradient is a measure of steepness of the line. The larger the gradient, the steeper or more vertical the line or line segment is. So the gradient, which for some reason we call m, it's equal to the rise over the run, or you can use this formula here. X and y are the points. So this would be x1, y1, x2, y2. So just so we note, if the line leans to the right, the gradient's positive. If the line leans left, it's negative. And if it's a perfectly horizontal line, the gradient's 0. So here, this line is leaning to the left. We're starting vertical and we're leaning to the left. So the gradient of this line is going to be negative. So the rise is how far we go up, and the run how far we go to the right. So this is the way I always teach it. Always start with the leftmost point. So that's here. So then go to B. So what we need to do to go to B, we need to go across 8. We need to go 8 to the right. To go from here down to B, we need to go 6 down. So the gradient of this line is rise. So I've gone 6 down over run, 8 across. So because it leans to the left, the gradient's negative. Another way to look at it is always start at the leftmost point and go right. If you then go down, the gradient's negative. If you were to go up, the gradient would be positive. So the gradient here is minus 6 over 8, or just simplified minus 3 over 4. So let's find the distance of this line segment. Well, to do that, I can just use Pythagoras. I can just make this into a right-angled triangle. One here, one here. The shorter sides are 6 and 8. So the distance is just going to be the square root of 6 squared plus 8 squared. I'm adding because I'm finding the hypotenuse of this right-angled triangle. So square root of 6 squared plus 8 squared is just 10, and I just write u for units. That is the distance of this line segment. So finally, we'll calculate the midpoint. The midpoint is the point along this line segment that's halfway between A and B. To do that, it's a very logical formula. So notice the formula's in brackets because the answer is a point. So we have an x coordinate and a y coordinate. You just add up the two x values and divide by 2, add the two y values and divide by 2. So what I mean by that is the midpoint, I'm just going to call it point C here. So all I do is take the two x values of the endpoints. So the x value of A was -2, the other x value is 6. So I go -2 plus 6 divided by 2. That's the x value. And then the y value, I do the same. I just add up the two y values and then divide by 2. And so adding those up, putting them in my calculator, I get to 0. That's this point here. So this point I've marked in green is the midpoint. All right, let's now go and look at finding the equation of a line. So on the previous slide, I plotted these 2 points and joined them up. I now want to find the equation of that line that goes through these 2 points. Whenever you're trying to find the equation of a line, there are 2 steps. You find M and you find B. The reason is because any line, its equation can be written in the form y equals mx plus b. So I just need to find M and find B. Now I found M on the previous slide by using rise over run. I'm just going to confirm my answer. So remember I gave you that second formula, y2 minus y1 over x2 minus x1. So here we have y2, which means y coordinate of the second point, minus y coordinate of the first point, all divided by x coordinate of the second point, minus x coordinate of the first point. So putting that on our calculator, we get -6/8, which is exactly what we got on the previous slide. So that's the first step done. I found the gradient of the line that goes through those 2 points. The second step is I need to find B. So to find B, I take my equation y equals mx plus b. What I'm going to do is substitute. So I'm going to substitute m for the value I just found. I just found m, the gradient, is -3/4. So to find b, I need to substitute a value for x and y. That will come from either of these 2 points. It doesn't matter which one. I'm going to choose this one. So here, x is -2, y is 3. So I'm going to rub out y and replace it with 3, and I'm going to rub out x and replace it with -2. So now what I will have is an equation, and I just solve this for b. So -3/4 times -2 gives us 6/4, or 1.5. So 3 equals 1.5 plus b, minus 1.5 from both sides. You get b equals 1.5. So remember, b is the y-intercept. So this line would have a gradient of -3/4 and a y-intercept of 1.5. All right, let's now look at doing the opposite. So now I'm going to give you the equation, and you're going to turn it into a graph. So there are 3 methods for graphing straight lines. The first is if it's x equals a number, it's just a vertical line. Y equals a number is just horizontal. These are kind of cases that don't fit into the other 2 methods. So the second method is called the gradient intercept method. You mark the y-intercept, b, and then you use the gradient to find a second point, and then just join them up. The third method is best used when you have an equation of this form. It's called the xy-intercept method. You let x equals 0 to find the y-intercept, let the y equals 0 to find the x-intercept, and just join them up. Methods 2 and 3 are just about finding 2 points through which the line passes and joining them up. So I'm going to do one of each type. So let's first graph x equals -3. Well, x equals a number is just a perfectly vertical line. So where would it be on the axis? It would go through x equals -3. So it would be this line here. So remember, when you're graphing lines, because they go forever in both directions, you need arrows and also need to label the equations. So that was an easy one. So let's look at this one, y equals 1 minus 3x. It's in the form y equals something, so we're going to use method 2, the gradient intercept method. So the gradient is always the number in front of x when it's y equals mx plus b. This is the gradient. It doesn't matter whether x is listed first or second. Number in front of x is the gradient. So the gradient here is minus 3 or minus 3 over 1. The other number by itself, that is b, the y-intercept. This line has a gradient of negative 3, a y-intercept of 1. So using this method, we label the y-intercept, which is 1, there. And we use the gradient to find a second point. So remember, the gradient is rise over run. The bottom number tells you how far you go right, and the top number of the gradient tells you how much you go up or down. Remember, if it's positive, you go up, negative, you go down. So because the gradient here is negative 3 over 1, I start at this intercept, I go 1 to the right, and I go 3 down. The reason I went down is because the gradient's negative. So 1 to the right and 3 down leads me here at the point 1 minus 2. So I'm just going to plot that point here, and now I'm going to join them up. And now we're done. All right, let's look at the last one here. So this is not in the form y equals something. So I can't tell just by looking at this what its gradient or y-intercept is. So I need another method, and that's method 3, the x-y-intercept method. I'm going to let x equals 0 to find the y-intercept. So if I take this equation and let x equals 0, this just becomes 0. I'm left with minus y equals 4. Or y equals minus 4. What I've found by letting x equal 0 is that the y-intercept of this line is minus 4. So I'll plot that down here. Now I want to find the x-intercept. If I let y equal 0, then I'm just left with 2x equals 4, divide each side by 2, x equals 2. The x-intercept of this line here is 2. So I'm going to put the point there, and now I'm just going to join them up. And there we have it. That's all there is to graphing. Now we're going to move on now to simultaneous equations, but I'm going to use this picture here. So simultaneous equation is when you get two equations like this, 2 and 3. Let's say we got these two equations. We want to find a solution that solves both of these equations at the same time. Simultaneous means at the same time. If I told you to solve these two equations simultaneously, that's actually asking you to find the point of intersection of these two lines. Now, we've actually just found that here. It's actually 1 minus 2. X equals 1, y equals minus 2 solves both of these equations at the same time. So that's what you're actually doing when you're finding simultaneous equations. You're finding their point of intersection of two lines. The problem is the point of intersection may not be so easily read. It could be like, minus 0.5 and 0.25. So we need another method that doesn't involve graphing to solve simultaneous equations. And that's what we'll go through on the next slide. So the idea here is simple. We have two equations and two variables, x and y variables. We don't know how to solve equations with two variables. We don't know how to solve something like x minus 8y equals 15. So what we're going to do is eliminate or get rid of one of the variables. So which one do we get rid of? Well, what you do is you get rid of the one that has the same coefficient or number in front of in both equations. So here, the y in both equations has an 8 in front of it. We are going to eliminate the y's. So how do we eliminate the y's? We either add together the two equations or subtract one equation from the other. So this blue box tells you when to add or subtract. So if the variable has the same sign in both equations, you subtract, and a different sign in both equations, you add. So what does that mean? Well, the y's, we said, have an 8 in front of them in both equations, but here they have a different sign, negative and positive. So what I'm going to do is I'm going to add together these two equations to eliminate the y's. So I go x plus 3x gives me 4x minus 8y plus 8y is 0. That's why I'm doing this. I get rid of the y's. 15 plus 13 is 28. So now I've got one equation with one variable x. So I'm going to divide each side by 4 now, and I get x equals 7. Now I'm not done. When you're solving simultaneous equations, you need a value for x and a value for y. So to find the value for y, I'm going to substitute this into the first equation. So I've got x minus 8y equals 15. Subtract 7 from both sides. Divide each side not by 8, but by negative 8, you get negative 1. So the solution here is 7, negative 1. X equals 7, y equals negative 1, x is always listed first. So what that means is if I were to graph this line and this line, they would intersect at this point. So let's look at this example, which is a little more difficult. So you can see neither the x nor the y has the same coefficient in both equations. When that happens, you need to multiply one or both equations. So I am going to try now to get the x's to have the same coefficient. So if I times this top equation by 5 and the bottom by 4, they will have the same coefficient. This will become a 20x. This will become a 20x. Then I will be able to eliminate the x's. So when I'm multiplying the top equation by 5, I need to multiply everything in the equation by 5. So 4x times 5 minus 3y times 5, 0 times 5. I need to do the same here too. 4 times 5x, 4 times positive 2y, 4 times 23. Now the x's have the same coefficient in both equations. I can eliminate the x's. They're both positive. They have the same sign. So this time, I'm going to subtract. I'm going to subtract the bottom equation from the top. So 20x minus 20x just gives me 0. The x's are eliminated. Minus 15y minus 8y gives me minus 23y. Now 0 minus 92 gives me minus 92. Now I have one equation with one variable. I divide each side by minus 23, so I get y is positive 4. Now I need to find x. I substitute into either equation. I'm going to substitute into this one here. So I have 20x minus 15 times y is equal to 0. Add 60 to both sides. 15 times 4 is 60. Divide each side by 20. So the solution here is x equals 3, y equals 4. That is a solution that solves this equation and also solves this one at the same time. So if I were to graph these two lines, they would intersect at the point 3, 4. Let's look at using simultaneous equations to solve a worded problem. So let's do this question here. Zoo enclosure has wombats and emus, 80 animals altogether, each wombat 4 legs, each emu 2 legs. Zookeeper counts 210 legs. How many of each animal is in the enclosure? So whenever you're solving a worded problem using equations or simultaneous equations, your first step is to define your variables. So we're going to let x equal one of the things that we're trying to find and y equal the other thing we're trying to find. So we want to find firstly the number of wombats and we want to find the number of emus. So after we have defined our variables, we're going to set up equations. This is a simultaneous equations problem. We have two variables. We need two equations. So the first bit of information says 80 animals altogether. So number of wombats plus number of emus equals 80. The second bit of information. So there are 4 legs per wombat. There are 2 legs per emu. And that adds up to a total of 210 legs. This is the hard part. Once we've got to here, all the hard work's done. We're just going to solve this like we solved simultaneous equations on the previous slides. Now, once again, neither x nor y has the same number in front of it in both equations, so we need to multiply. So this time, I'm going to multiply the second equation by 2. So that will ensure that the y's have a 2 in front of them in both equations, and I can eliminate the y. I'm not going to do anything to the second equation. So multiplying the top equation by 2, x times 2, y times 2, 80 times 2. Now I have 2 equations. The y has the same coefficient. I can eliminate the y's by subtracting. So I'm going to go 4x minus 2x is 2x. 2y minus 2y is just 0. Y's are gone. 210 minus 160 gives me 50. So I get 2x equals 50. Divide each side by 2. X is 25. So if x equals 25, y will be 55. 25 plus 55 equals 80. So that means there are 25 wombats, which gives us 100 legs, and there are 55 emus, gives us 110 legs. All right, and then we're done. Now let's move on to geometry. So we're going to look at similar triangles. So two shapes we say are similar if both of these conditions are true. Pairs of corresponding sides are in the same proportion and pairs of corresponding angles are equal. If two shapes are similar, it basically means one is just an enlargement of the other. So here we've got some quadrilaterals. So let's look at these two squares. Well, they have all angles equal because all 4 angles of a square are 90 degrees. The sides are in proportion. So each side of this square is 4, each side of this square is 2. So they're in proportion because each side in the larger shape is double its corresponding side in the smaller shape. This side is double this side. This side is double this side. This side is double this side, and so on. So these two squares are similar. In fact, if you get 2 squares, they will always be similar. So these two are rectangles, but they're not similar. Now, even though rectangles have all angles equal to 90 degrees, so pairs of corresponding angles are equal here, the first condition isn't satisfied. Here the sides are not in proportion. This side is double this side, but this side is not double this side. So these two are examples of shapes that are not similar. So we looked mostly at similar triangles. Triangles are really good to work with for similarity because to check if they're similar, we don't need to check every pair of sides and every pair of angles. We can use one of these 4 tests. So the first test here, SSS. S means sides in proportion. If you have 1, 2, 3 pairs of sides in the same proportion, then the 2 triangles are similar. I don't even need to check. I know that pairs of corresponding angles will be equal. So in proportion means the same scale factor. So here, 6 over 3 equals 5 over 2.5 equals 4 over 2. Each of those is equal to 2. What does that mean? Each side in this large triangle is double its corresponding side in the smaller triangle. So that is the SSS test. So SAS test is a little more difficult because it must be 2 pairs of corresponding sides in the same proportion and the angle between them. So if I look at these 2 triangles, 9 over 6 is equal to 6 over 4. Both are equal to 1.5. What does that mean? This side is 1.5 times this side. This side is 1.5 times that side. So that means there are 2 pairs of sides in the same proportion. The angle between them is also equal. That's what the SAS test means. So these 2 triangles are absolutely similar. So let's look at these 2 triangles. So there's the small triangle and the large one. So it turns out they will be similar. This angle is in both triangles is common, and this angle here is corresponding. So if 2 pairs of angles are equal, that means the third pair must also be equal because the angles add up to 180. So if you have two triangles and they have three pairs of equal angles, three pairs of corresponding angles that are equal, then they are similar. This small triangle and this large triangle are similar. So let's look at the last test, RHS. You can only use this in right-angled triangles. That doesn't mean that if you have two right-angled triangles like we did up here, then it must be RHS. You can only use this one if it's right-angled triangles though. So here we have 9.6 over 8 is equal to 1.2. 6 over 5 is equal to 1.2. I have two pairs of corresponding sides in the same proportion. This side's 1.2 times that side. This side's 1.2 times that side. Now notice this time it's not the angle between the two pairs of sides in the same proportion. What I have is R, a right angle in both, and I have the hypotenuse in the same proportion as another side. That's what the RHS just means. It allows you to use two sides and an angle without it being the angle in between, but once again, you can only use RHS in right-angled triangles. So similarity helps us to find unknown sides. We'll look at that on the next slide. So, if two shapes are similar, their sides will be in the same proportion. We can use that to find unknown sides. So the scale factor is the side in the larger shape divided by its corresponding side in the smaller shape. So what you do to find unknown sides using similarity, you first calculate the scale factor. If you're finding a side in the larger shape, you times by the scale factor. If you're finding a side in the smaller shape, you divide by the scale factor. So let's look at this small triangle and this large one. They're actually similar by the AAA test. We have vertically opposite angles. These two angles are alternate. And as I said, if two pairs of angles are equal, the third will be equal. Okay, so these are similar triangles. Their sides will be in proportion. So to find the scale factor, I need two pairs of matching sides. So here I have 15 and 8. So the scale factor will be 15 over 8. So 15 over 8 is 1.875. That means each side in the larger triangle is 1.875 times its corresponding side in the smaller triangle. So let's look at finding x. X is in the smaller shape, so we're going to divide by the scale factor. So we need to know which side corresponds to x. Well, x is touching the cross and the arc, so it corresponds to the side touching the cross and the arc. X and 12 correspond. So in this triangle, x will be 12 divided by the scale factor of 1.875. So putting that on our calculator yields x is 6.4. So now let's calculate y. Well, y is in the larger shape, so we're going to times by the scale factor. Y corresponds to this shape that's 6. So it's going to be 6 times 1.875, which is 11.25. And then we're done. All right, let's look at this second pair of triangles. This one's a little more difficult. Now, the two triangles are again similar by the AAA test. They have a common angle and two pairs of corresponding angles. So because they're similar, sides will be in proportion. So the scale factor, a lot of people would say it's 6 over 4, but it's not. 4 is not in the triangle. This side in the larger triangle is equal to 6 plus 4 is 10. So the scale factor here is the side in the larger shape divided by corresponding side in the smaller shape. So it's 5 over 3. So let's calculate y first, because y is easier. So y corresponds to the 4.2 side. So y, because it's in larger, is just going to be 4.2 times the scale factor of 5 over 3. And so using your calculator, you get y equals 7. Now calculating x is harder because we don't know the length of this full side. So the side in the smaller triangle is x. The side in the larger triangle is x plus 5. So what scale factors mean is, if I times the side in the smaller shape, x by the scale factor, I get the side in the larger shape. So we're going to solve this equation. Now, when you have an equation in which the variable's on both sides, you subtract the one with the lowest coefficient. This is just a 1x. So if I subtract 1x from both sides, I get 2/3 x equals 5. So I'm going to undo timesing by 2/3 by dividing by 2/3. So x will just be 5 divided by 2/3, which is 7.5. So that one was a harder one. Please let me know if you didn't understand it. All right, now we're going to go on to trigonometry. So trigonometry, like Pythagoras, is used in right-angled triangles, but unlike Pythagoras, it involves angles. So we're going to use trigonometry to find unknown sides and also an unknown angle. So let's look here. We're going to use trigonometry to find x. So whenever you're finding an unknown side or angle, your first step needs to be determining which ratio you will use. There are 3 ratios. Sine, which is opposite over hypotenuse, cos, which is adjacent over hypotenuse, and tan, which is opposite over adjacent. Remember SOHCAHTOA? That tells you when to use which ratio. So remember, if I have an angle, not the right angle marked, the side facing it is the opposite side. The side next to it's the adjacent. The hypotenuse is always the one facing the right angle. So in this triangle here, I have, for this 30-degree angle, the opposite side and the hypotenuse. Opposite and hypotenuse means I use sine. So I set up my equation like this. Sine of angle equals opposite over hypotenuse. So in this triangle here, compared to this angle, I have the adjacent and the hypotenuse. So adjacent hypotenuse means I use cos. So I'd set it up as cos of angle, this time 22.6, equals adjacent over hypotenuse. So now I need to solve these 2 equations. So they look slightly different. In this one, the x, the thing I want to find, is on top, and here, the x, the thing I want to find, is on the bottom. When the thing you want to find is on top, you times. So the way I solve this equation is x equals 8 times sine 30. You need to make sure your calculator is in degrees. You should get the answer of 4. When the thing you want to find is on the bottom of the fraction, like it is here, you divide. So x is going to be not 10 times cos 22.6, 10 divided by cos 22.6. And so the answer I get is about 10.83. Once again, make sure your calculator is in degrees mode. All right, for this last one, we're actually finding an angle. So when you're finding an angle, you don't use sine, cos, or tan. You use sine inverse, cos inverse, or tan inverse. So because I have opposite and adjacent, I want to use tan. So I will have theta equals tan. Now, because I'm finding an angle, it's tan inverse. That's what this little one means, inverse. So the way you bring that up on your calculator, you press second or shift and then tan. So you get tan inverse of opposite over adjacent. Remember with SOHCAHTOA, whichever one's listed first goes on top. So because the opposite's first, opposite goes on top, adjacent goes on the bottom. So if you put that on your calculator, you get about 33.69 degrees. And that is the answer. How easy is that? All right, final thing on this video, angle sum of a polygon. So remember, the angle sum of any triangle is 180 degrees. Doesn't matter whether it's a right angle triangle or scalene, it's 180 degrees. If a shape has n sides, you can draw n minus 2 triangles in it. So that means if you have a 10-sided shape, you can draw 8 triangles in it. If you have a 7-sided shape, you can draw 5 triangles in it. So the angle sum of any polygon is just 180 times the number of triangles. It's 180 times the number of sides minus 2. So we can use that to find unknown angles. So let's look at this shape here. This shape has 7 sides. So that means all of the angles inside the shape will add up to 180 times 7 minus 2, which is 900. So because I know what the angles need to add up to, I can find what x adds up to really easily. So 140 plus 110 plus 90 plus 140 plus 135 gives me 615. So 615 plus x must equal 900. So I have 615 plus 2x equals 900. You know how to solve this. Just subtract 615 from both sides and then divide each side by 2. So x is 142.5 degrees. How easy is that? So now looking over here, we have a 6-sided shape. So all of its angles will add up to 180 times n is 6, number of sides is 6, minus 2, which is 720. All of these angles inside, these 6 angles must add up to 720. Now this shape is regular. So a regular hexagon, what it means is all of its sides are equal, but all of its angles are equal. So each angle inside the shape is going to be the same, so I can just divide 720 divided by 6, and I get 120. All right, sorry for such a long video, but best of luck in your final exam. You'll ace it. You're a superstar. This has been the luckiest maths teacher in the world. Have a great day.